let's talk about graphing this from start to finish. This is a weird looking function, right? There's a lot going on with it. We know that there's probably some factoring to be done. But the first thing we want to do whenever we're graphing a rational equation is to make our plan. So my plan always starts with step one, which is factor. Okay. We have to factor it. We have to see which little individual components make up the numerator and the denominator. Because once we factor, then we can start doing some of the real math there behind rational equations. So after we factor, we're going to find any asymptotes. All right, we're going to find any asymptotes. Then we'll look for any holes algebraically in the graph. And then we'll look for intercepts of any kind. And then usually I like to do some extra points like with an XY table. Okay, so that's the plan for this rational function, and let's get started. Okay, so I do have to keep the function visible, but I'm going to have to hide our plan so I can show you step by step. So number one is going to be to factor. Okay, now I suggest that you try and pause the video right now, do it on your own, and then you can watch me, fast forward, do whatever you will with the video. Okay, so if you want to give it a try right now, pause it and factor. Okay, welcome back. So first things first, I see a 2, and a 12. So I'm going to take that out, and I'll be left with x squared minus x minus 6. And I look at the bottom, we have a coefficient of 1. So I'm looking for two numbers that multiply to 8 and add up to 6. And that is going to give me x plus 2 and x plus 4. So factoring further, I need to think of two numbers that multiply to negative 6 and add to negative 1. And that's going to be x minus 3 and x plus 2, because we still had that negative constant there. And then we'll have x plus 2 and x plus 4. So one thing that you probably notice right now is that we can get rid of our factor x plus 2, right? So we're going to just do that very lightly because we need to remember that it's there. So we'll just say there is a hole at, let's see, x equals negative 2, and we'll take care of that in a minute. So that's the first step. Let's factor, right? That was number one. Number two, we are going to look for any of the asymptotes. So take a minute, try and see if you can get those asymptotes without my help. Pause. All right, welcome back. So asymptotes, we are going to look for any vertical asymptotes first. It doesn't matter. You can do horizontal first. I just choose to do the vertical because those are the ones that are not going to be removed from our denominator, right? So x plus 4 is going to create x equals negative 4, and that is going to be the first thing that we graph. So I'm going to use some different colors. So we'll start off with, I don't know, I'm feeling crazy. Let's start off with the purple. So x equals negative 4. So I'm going to go down to the bottom here, and we will graph that right there. Okay, I think that was a reminder. Okay, we're good. So there's our asymptote at x equals negative 4 in purple. Okay, the horizontal asymptote is something that we have to look at the simplified version of our function. So if I simplify that, take out our x plus 2's, I'm left with 2 times x minus 3 over x plus 4. Okay, so I'm looking at that and I realize, okay, wait a minute, we have 2x over x if I were to simplify that. So that means we have the same degree on the top and the bottom. So we're going to take the coefficient of those two. It would look like this, 2x over x, and that tells me that our horizontal asymptote is at y equals 2, because the ratio of 2x to x would simplify down to 2, okay? So we're going to say y equals 2 for the horizontal asymptote, and I'll go over and we'll do this one in orange. Okay, so orange, y equals 2, and then we'll go across. Perfect. Okay. No way to make those dashed unless we were to erase a little bit each time, and I don't really have the patience for that right now. So, all right. Asymptotes are all set. We did have a second factor down here in the denominator that was canceled out. So we're going to take a look at that hole right now with step 3, and we know that x equals -2 is the x location of that hole, but we don't know where it is on the y-axis. So essentially we're trying to figure out where is that going to manifest itself on the actual graph. So I look over here at the simplified form. Let's bring that over here for you in a different color. So I've got y equals 2 times x minus 3 all over x plus 4. So I need to substitute -2 into there. So we will say 2 times -2 minus 3 over, and that's going to be -2 plus 4. Okay, make sure we're good. You can see that. And we have 2 times -5. Sorry, I'm doing that a little quick in my head there. And then we have over the number 2. So what's nice about leaving that factor of the 2 out there, we can just reduce it and we get -5. So our hole is at -2 comma -5. And we'll go with a different color on that. Let's do a green spot. So -2, -5. And I'm just going to make a little circle there. That looks pretty darn good. Okay, so step 1 was to factor, step 2 was to find the asymptotes, and step 3 was to find the hole. So from there, I think it's a good chance to just pause, make sure your graph looks like mine, and then I will turn the page for step 4. So pause if you need to. So just taking a look at our plan, we factored, found the asymptotes, found the holes, and now we need to find those intercepts. So I am going to save my factoring from the last page. And we know that our equation looks like this right now. Over x plus 4. So we know that we need intercepts, right? Intercepts are going to look like this. We're going to either have something with a 0 in for y, or we'll have 0 in for x and then something in there for y. So I don't even worry about labeling them x and y, but you can remember that if you're finding a number for x, that's the x-intercept. If you're finding a different number for y, that's the y-intercept. So anywho, first to get y equal to 0, we're going to set the numerator equal to 0. And we're going to say 2 times x minus 3 equals 0. And we could divide out the 2. So really we just have x minus 3 equals 0. And x equals 3 is one of our intercepts. So we're going to go over there and we're going to graph 3 comma 0. So I will just choose blue. 1, 2, 3, and we'll make a point there. Okay, so all of a sudden you can see this function looks like it's going to kind of go through this lower right hand side portion. And let's see, another intercept. We need to substitute 0 in for x. So looking up top here, we're going to have y of 0 equals 2 and then 0 minus 3 over 0 plus 4. And this equals 2 times -3, so -6 over 4. And then we can divide each side by 2. We get -3 halves. So -3 halves is our other intercept. And I'll graph that one in red. Okay, so 0, -3 halves. That's -1. And it's right about there. Okay, so I have 3 points over here, right? So I'm just going to take a black line now, and I'm going to try and draw through that curve. I'm not going to draw through the hole, try and really make that one obvious. And then I'll go on the asymptote here, and then we'll draw a little arrow on that side as well as this side. Okay, I don't like that. Let's get a better one. There we go. Good. Okay, so you notice that we're kind of like needing a little bit more to this function. We know that there's usually two sections of it, of a rational curve. So I'm anticipating the curve to be somewhere around here. But for us to figure out where that curve actually is, well, we want to just plug in some points and find a few more xy coordinates. Okay, usually in class we would go with a standard of 2 coordinates. So let's see. Let's remind ourselves that the function is looking like this. Okay, function's looking like this. And I'm just trying to find a strategic x value to plug into this equation that's going to make a really clean denominator, like a 1 or a 2, some small number that we can divide by, right? Or a -1 or a -2 for that matter. So as I look on this side of the asymptote, I see -5, and I'm thinking, okay, -5 plus 4, that would make -1, right? So that's going to make some clean calculations. So we're going to try -5 in there. So let's plug in -5. We get 2 times -5 minus 3 over -5 plus 4. Like we said, that's going to make a -1 on the denominator. Good stuff. And then we've got 2 times -5 minus 3 is going to be -8. So that's -16 over -1. So that's going to be a positive 16, and that's off our graph a little bit. So that is very unfortunate for us, but I'm going to just put one up here. And I thought that scale was going to be better, but that's okay. So it's going to be way up here, okay? And then let's just try another number to try and see. Maybe that was a little too high, so maybe let's try -6. So if I plug in -6 here, we're going to have 2 times -6 minus 3 over -6 plus 4. Okay, so here we have 2 times -9 divided by -2. All right, that is giving us, well, we could say -18 over -2 or just +9. So there we go. We got one on the curve now. So just to remind you, that's -6 comma 9. And I can go to -6 comma 9. And we're up there. Okay, so remember that point right there should actually be a little higher, but what are you going to do? And I'll pick one more point because I'm curious to see how low this will go. So let's do, well, we already did -6. Let's try -8. We'll skip a little bit. So I'll substitute -8 in there. All right. We have 2 times -8 minus 3 over -8 plus 4. And I have 2 times -11 over -4. And we're going to have to approximate, but -22 divided by -4, that's approximately 11 over 2, right? If we make those both positive, 22 over 4, divide each side by 2, 11 halves, or we know that as 5.5. So -8 comma 5.5 is that last point. And let's try that. -8, 5.5. So you can see this curve is looking kind of crazy. It would come down like this and swoop through like that. Okay. Sorry, I didn't go through all of those points, but rarely do we ever, right? Good and good. Okay. That's okay. So I hope you enjoyed this tutorial. We're going to do another one of these on the next slide, but I'll probably give you a chance to try one out on your own in between. All right. So we will see you soon, and good luck graphing rational equations.